When we're trying to find exact coordinates on the unit circle, there are several spots where we need to recognize right away, and they're starting off in the first quadrant. We have a 30-degree angle, a 45-degree angle, and a 60-degree angle that we're going to be focusing on. Once we know those, we can get the same coordinates in the second quadrant, the third quadrant, and the fourth quadrant. We also should be able to get the exact values at these spots here. So this would be 1, 0. This would be negative 1, 0, because the unit circle is placed at the origin. This spot up here is going to be 0, 1, and this coordinate down here is going to be 0, negative 1. If we take a look at this triangle right here, it's a 30-degree angle. It's a right triangle. So when I want to figure out this coordinate right here of that point, I need to figure out my x value and my y value for that point. Well, my x value is going to be, using Pythagorean theorem, square root of 3 over 2, because my hypotenuse is 1. My y value is 1/2. Therefore, my coordinate is going to be the square root of 3 over 2, 1/2. Now, I also have this triangle over here. This is a 30-degree angle here. This angle here is going to be 150 degrees. And my coordinate point now is going to be based off the blue one that I have already. My distance along this way is the same distance I had for the blue triangle. So it is the square root of 3 over 2. However, since we are on the unit circle and we are centered at the origin, this is a negative value. I am still now going in the positive y value of 1/2, so my coordinate is the square root of 3 over 2, negative square root of 3 over 2, 1/2. Then I have this yellow triangle. You can see the yellow and the red actually share the exact same x value. So my x value is negative square root of 3 over 2. And my y value now, for that coordinate, is no longer a positive 1/2, it is now a negative 1/2. And I have one more in the fourth quadrant, the green one. And as you can see, the blue and the green share the exact same x value. And the y value now is a negative 1/2. So all four of those triangles are based off the blue one. If we take a look now at this blue triangle, which is a 45-degree angle, again, it's a right triangle. And again, the hypotenuse is 1 for the unit circle. And going through Pythagorean theorem, I get the square root of 2 over 2 for both these sides. It's an isosceles right triangle. Therefore, this coordinate is square root of 2 over 2, square root of 2 over 2. Now, using the same idea as we just did with the last one, I have this green triangle here. This value here is square root of 2 over 2, but again, being in the second quadrant, it is a negative value. And this side is, again, square root of 2 over 2. My coordinate then being negative square root of 2 over 2, square root of 2 over 2. For the yellow triangle, it shares the exact same x value. And now my y value is also negative, being in the third quadrant. And with the red one, it shares the x value of the blue, so it's a positive square root of 2 over 2. But now the y value is negative. Our last option here would be the 60-degree triangle. This is going to be just like the 30-degree triangle we did before, only rotated. So now this side is our 1/2, and this side is our square root of 3 over 2. So our coordinates actually flip. 1/2 square root of 3 over 2. Our next option is the green one, where we have a negative 1/2 and a positive square root of 3 over 2. We have our yellow one down here, which shares the same x value of negative 1/2, and now a negative y value. And we have the red one, which shares the x value of the blue, positive 1/2, but a negative y value. And those are all of our exact coordinates on the unit circle.